Today we will be reviewing our SOL 6.16, which is probability. And if you remember probability, probability is the chance that something will occur, whether it be your chance of winning the lottery, your chance of getting struck by lightning, the chance you'll roll a dice of a certain number, the chance you'll pick a card out of a hat. It's just the chance of something occurring. And we talked about two different types of probability. We looked at independent and dependent. So first off, I just want to review what independent probability is. An independent probability is when one event does not affect the outcome of another. Like if we spin a spinner and roll a dice. What you do in your spinner has absolutely no effect on what you get on your dice. They do not affect one another. In real life problems, a good does not affect might be a keyword of replacement. Say you draw a card and then you replace it. That means that it's independent probability. It's when two things do not affect one another. So let's read this example together. A coin is tossed and a number cube is rolled. Find the probability of tossing tails and rolling a 5. So let's think about this. You toss a coin. What are our two options on a coin? We can either get a heads or a tails. So it wants us to get a tails. So we make a fraction. And what is our fractional chance of getting a tails? And that is 1 out of 2. And then we have a number cube. Remember, that's a fancy thing for a dice. And we know the numbers on a dice are 1, 2, 3, 4, 5, and 6. And it wants the probability of rolling a 5. So we look and we see, well, there's 1 5 out of 6 numbers. So that's a 1 in 6 chance. And because we're doing both things, it says and, we are going to multiply. And remember, when we multiply fractions, we do our numerators, 1 times 1, and our denominators, 2 times 6, which would be 12. When we say we have a 1 in 12 chance of tossing a tails and rolling a 5 at the same time. So we have this chance right here. So independent probability. Had this been a fraction that needed to be simplified, we would need to simplify. So let's look at the next one. Dependent probability. When one event does affect the outcome of another. So this is like when you draw a card and you keep it out of the deck. So now you have a whole new set of chances of drawing another card. This would be when you eat pick candy out of a jar. Let's say Timmy gets to go first and Timmy picks out the only sucker. Well, all of a sudden that means there's only one sucker. So it's gone. That chance doesn't, it affects the next person's chance of getting it. So let's look at this next one. All right, I'm going to go and put this here, without replacement. Without replacement. So for example, a bag contains 7 blue, 3 green, and 3 red marbles. If Agnes randomly draws 2 marbles from the bag, one after another. So since she's doing one after another, it's telling us that she's keeping them out. What is the probability of drawing a green marble and then a blue marble? So let's look up here. What is her chance of getting a green that first time? Well, there are 3 out of how many total marbles are in the bag? Let's see. 7, 8, 9, 10, 11, 12, 13. Now here's where it changed a little bit. She's doing 2 things because it says and, so we're going to multiply. But what's her chance of getting a blue? Well, there's 7 blues, but no longer are there 13 marbles. Because she grabs them one right after another, there's no longer 13 because she took out a green the first time. So now there would be only 12 marbles. Now we can multiply straight across if you like, and that would be okay. We could do that. If we multiplied straight across, we would get 3 times 7 would be 21. 13 times 12 would be 56. And then we would have to simplify, which it can be simplified. It can be simplified by 3's. And you can use your calculator to do this. You can't actually do the fraction, but we can do 21 divided by 3, which would be 7. 156 divided by 3 is 52. And that would be as simple as it can go. Now, some of us are not big fans of having to do this way, but you like to cross simplify. So at the very beginning, you could have cross simplified. We could have looked at this 3 and 12 and known, hey, I can divide both those by 3. 3 divided by 3 would be 1. 12 divided by 3 would be 4. Which would just make my life easier. So now when I go to multiply, I would multiply 1/13 times 7/4, which improper is okay, as long as it's not your final answer. 1 times 7 would be 7. 13 times 4 would be 52. So you get the same answer either way, just it saves us having to do this big simplifying right here in the middle if you simplify the beginning first. Before you move on, if you will go over here to number 2, the copier cut that one off, so you can go ahead and mark out number 2, and then you may begin doing the work.